Hello, and thank you for tuning in to the presentation of our paper, The What, Why, What If, and How To for Designing Architecture, which concerns itself with the explainability for auto-completion of computer-aided architectural design of floor plan layouting during the early design stages. My name is Jessica Bieski, and I'm presenting on behalf of our research group called the KSD Research Group, involving my current colleagues Christoph Langenhahn and Victor Eisenstadt, and our former colleague Christoph Ziegler, and also our supervisors Frank Petzold, Andreas Dengel, and Klaus-Dieter Althoff. Let's start out with addressing the contemporary context. So the world population is expected to reach the 10 billion mark within the 2050s, with about 2/3 living in the metropolitan area, which poses major challenges on the building industry and especially on housing, of course. So the architects of the future need to work faster and more efficiently while increasing the architectural quality, which involves the build quality, the context, and also the aesthetics, of course. On the other hand, artificial intelligence is already established in many fields of research and also everyday life. For example, digital keyboards of smartphones, which accelerate the writing of words and sentences through auto-completion techniques. We draw from Wang and co-authors, who present a framework for creating theory-driven explainability for a specific target group. It is based on the dual process model of ideal human reasoning and true human reasoning with errors, of both heuristic system 1 and the analytical system 2. Thus, explainability either supports the human reasoning process or mitigates possible errors. Based on 4 common biases of cognitive sciences, which are the representative bias, the availability bias, the anchoring bias, and the confirmation bias, but it's also for moderating trust because of weaknesses of system 2. They also added adaptation steps for creating explainability for a specific target group, which starts out with clarifying the user's reasoning goals and possible biases through literature review, ethnography, and or participatory design. Then also deduce the appropriate explanation ways for reaching the reasoning goals and or mitigating cognitive biases using the pathways of the framework, so the blue lines that says informs. And finally, integrating the explainable intelligent system facilities to create an explainable user interface. The findings of this theoretical review are discussed in another paper in detail. We're going to focus on the integration into a paper prototype and also how to use it in a case study, and thus all of these errors, etc., and how to mitigate them are explained by the means of it. The paper prototype is created based on the findings, like I said, as a high-fidelity click dummy with the program ProtoPy. In the picture you can see the main view with all drop-down windows and also the toast notification. I'm going to talk about the explanation visualization in detail going along and their purpose while they're being highlighted. I'm going to start with how we are supporting the human reasoning process of architects, and then we are moving along how to mitigate the biases of heuristic system 1, finally followed by the weaknesses of system 2 and how we're going to address them. The integration in the paper prototype is far and foremost for reasoning support. It is built on the findings that architects mostly use inductive, so bottom-up, and analogical, which is a kind of bottom-up, but based on a singular instance, reasoning methods of architects. Therefore, we answer with contrastive, why, counterfactual, what if, and transfactual, how-to explanations. And for example, for the visualizations, we use the comparison of multiple sketches. So we offer alternatives, which are also highlighted with color coding. So we support contrastive reasoning. But also we address the counterfactual and transfactual reasoning with simulations, for example, with daylight simulations, which can be done for sketches. Further, we're assuming the position that the architectural design process is an analytical hierarchy process called an AHP with multi-criteria decision-making, so an MCDM. Thus, if we rectify the skewed criteria ranking by supporting the reasoning process, we are also mitigating the anchoring bias of architects. To further mitigate the anchoring bias, we also offer the design conditions, called the building context, on how the system categorizes the drawn sketch. So, for example, we have a building type or a floor plan type. But this also addresses the representative bias, because not only offer we not only offer the building context of the drawn sketch, but also the design conditions. Then we are going to talk about the toast notification when accessing the actual suggestion view, which says suggestions shown ranked by likelihood, which are generated through prior probability, and it aims to mitigate the availability bias. So, what is actually the highest probability? Well, on the right you can see mitigated through transparency, scrutability, and debugging options for moderating trust between the architect and the hypothetical intelligent design assistant white bridge. So, for example, we show how the system recognizes the rooms within the sketch of the architect, as well as how, through coloring and hatching. For example, we have light brown color with a wood flooring to show that it recognizes it as a bedroom. Further, on the upper right, we have the confidence of the system, which displays how confident the system is in the own classification of the drawn sketch. So 82%, I'm quite sure that this building type is residential housing, at 92%, so also with subcategories. Then we finally have the access to the raw data for scrutability and mostly debugging in a second step. So we before saw the building context information of the floor plans generated used for generating the suggestions on the upper right, and it had a tiny button on it that said more details of the building context information, and that's how we can access the floor plans. Which leads us to how we're utilizing a paper prototype within a study. We conducted the study participants were sessions via Zoom and consisted of watching the video, answering any questions of the participant, and then were followed by a semi-structured interview with 3 question sections: the explanations, the explanation visualizations, and the user perception. The video was recorded and transcribed, and then there were 2 kinds of interpretation basically done simultaneously. One was that the participants' answers were enriched with the notes of the researcher taken during the respective session, revised and finally interpreted by the researcher into 1 mind map per question section, and simultaneously an algorithm was used to interpret the participant expressions as word clouds and represent the frequency of certain words through size, and it was 1 word cloud per question section. Which leads us to the conclusion and the future work. The study results suggest that the architect's cognitive horizons are indeed broadened, and that is because the participant often themselves recognize opportunities provided by an intelligent design assistant. For example, they would say, it gets me out of my comfort zone with the other alternatives, or I see my own habits more. However, if the user feels deprived of ownership of their own design, they become suspicious of the application. And finally, the visualization of unknown and uncertain aspects, for example, the material category of the building context information, can be irritating, and that even extends to the user perception of the entire intelligent design assistant application, which also confirms Lawson's sentence that it disrupts design flow if the application is suggesting that more is known than actually is. However, overall, the participants agreed that they felt more confident in taking certain design decisions because they felt validated by the system, and thus they could take individual design decisions faster, and more confident, and thus the overall design process was accelerated while they felt relieved stress. Thus, overall, we contribute an approach adapted to the domain of architecture for designing and visualizing explainability for intelligent design assistant, utilizing digital paper prototypes and case studies. And for our future, we want to integrate the immediate findings of the study, for example, removing the material category, but also want to further investigate this topic of the temporal aspect of explanation. When is what needed? If you're interested, you can watch the full narrated video of the paper prototype as presented to the study participants via the link or the QR code, and thank you very much for your attention.